Okay. So properties of covariance also, let me talk before going to the correlation concept. Okay. How covariance is used, or how covariance and correlation are interrelated. Covariance of x plus a and y plus b, if I talk about, there will be similar to variance, there will be no covariance of a constant. It's just the covariance of the variables that I'll be having. Covariance of a constant would be 0. Okay. Suppose if I have covariance of ax and by, then a and b would be pulled out, and then it would be covariance of xn. Okay. And then how do I define covariance? Apart from covariance of x comma y, how do I write it mathematically is 1 by n summation I is equal to 1 to n. Okay. Xi minus x bar into yi minus y bar. Previously, in the previous video, I have written it in this format: E of x minus x bar into y minus y bar, or it is the same as expectation of xy minus expectation of x into expectation of y. Okay. There's one condition which I'll talk about, but whichever one, whether if this is easy, if the data has been given to me like this, where I have x values and y values in a table, I'll be using this formula. If I have things in terms of mean and all those, I'll be using the other formula. Okay. Depending on our convenience, we'll be using one or the other. Accordingly, we'll be using those formulae. Okay. Now, if at all if x and y are independent, see, if I have two independent variables apart from the note 1, this is note 2. Of course, this is the definition in a different version, so this need not be known. If x and y are independent, okay, then there will be no covariance. Now, one will not be varying with the other. Na? So what happens is, covariance of x comma y is nothing but e of x into e of y minus e of x into e of y. Okay. Or in other words, for independent events, we would have seen in the probability for independent events, e of x into y would be e of x into e of y. Both are independent. If they are dependent, then conditional probability comes into picture, kind of things. Okay. So both of them will go off. So covariance would be 0. If x and y independent, okay, covariance would be 0, right? This is how, these are some of the properties of covariance. I'm not doing any problems on covariance. I'll directly do how correlation and covariance are related. There's one important thing, the Karl-Pearson coefficient of covariance, which would be important, and Karl-Pearson coefficient of correlation. Karl-Pearson coefficient of correlation. Of course, there are many. Spearman coefficient of correlation, rank correlation also is there. But then here in this video, I'll be talking about Karl-Pearson coefficient of correlation. What's the formula like? Usually, what correlation stands for is, it analyzes the behavior. Correlation analyzes the behavior of two or more variables. Analyzes the behavior of two or more variables. Okay. Some mathematical relationship. Analyzes means it analyzes the quantitative relationship. Quantitatively, it gives some number. Analyzes the behavior of two or more variables. Two or more variables. I'll just say quantitatively, not qualitatively. Good, better, best, not like that. Quantitatively. Okay. Yes. That's what is correlation. It is denoted by small r. Denoted by r. Okay. How is r defined as covariance of x and y by covariance of x and y by standard deviation, SD. SD is the shortcut for standard deviation. Standard deviation of x into standard deviation of y. Okay, that's how correlation is being defined. Or I will just write like this: R is equal to covariance of capital X comma capital Y by sigma X sigma Y. Okay. Yeah. So depending on the problem, I'll be finding out the things. If covariance is being given, fine. Otherwise, if covariance is not being given, if I'm being given something like xi's and yi's or data in terms of x values and y values, then I'll be using this formula of covariance. That is xi minus x bar into yi minus y bar by n is there. No? Yes, by n is there. Sigma x, sigma y. If you ask me, what would be sigma x and sigma y? Let me finish off writing that. Sigma squared x or sigma x, anything I can write. Sigma squared would be no root. If sigma is there, it would be positive root. Of what? Variance, that's it. Summation xi minus x bar whole square. Okay. Because sigma is there, I am putting positive root. Sigma y also would be similarly in terms of y. 1 by n summation yi minus y bar whole square. Okay, of course, I ranges from 1 to n, depending on the data points, how many data points are being given. Right? Accordingly, I'll be calculating. Yeah. Now, let me do one problem on correlation. Okay. On otherwise, let me first just the properties of correlation, then talk about a problem. Okay. Properties. Properties of R, the correlation. Okay. What are the properties of R? First property is, everyone has to remember this. What that is R value lies between -1 and +1. It cannot cross more than that. It can't be more than that. Especially Spearman, Karl Pearson rank correlation coefficient cannot numerically exceed -1 and +1. The limits are this. Now, if you ask me, what if R is equal to 1? What do you talk about the correlation? It's a perfect positive correlation. Perfect and positive correlation between the variables. Okay. If R is negative, then perfect negative correlation. Perfect and negative correlation. Okay. If R is equal to 0, then no relationship. If R is equal to 0, that means obviously this implies numerator is 0. Numerator is covariance, right? Covariance is 0. That means what? Variables are independent. No relation. No relation. Between x and y, I will write here because we are talking about two variables here. Okay. Then correlation is independent of change of origin and scale. Of course, if you remember or not, just make a note of it. Correlation R is independent. Whereas regression is not like that. That's why he is specifying. R is independent of change of scale and origin. Shifting of origin, I should say. Shifting of origin. Okay. Basically, these are the properties. Of course, if two independent variables are there, they are not correlated and all those things. Anyways, I have discussed. So I think this much is enough, right? These two properties, especially the bound between correlation is what you ought to know. Okay. Let's do problem in the next video.